Hello everyone, welcome to lecture 28, solving trigonometric equations. So in the last lecture, when we talk about inverse trigonometry functions, there's situations where you are given the solution of psi, let's say psi of theta equal to a certain number and you're looking for the value of theta. However, in inverse trigonometry functions, we sometimes have to restrict the function in certain interval. For instance, for psi functions to be a one-to-one function, you have to restrict the domain between negative pi over 2 to pi over 2, and including the endpoints. For cosine function, we have to restrict the domain between 0 to pi, and including the endpoint. For tangent function, we have to restrict the domain between negative pi over 2 to pi over 2, and we do not include the endpoint. And given the sine function, cosine function, and tangent function of some theta equal to a certain value, we are asked to find the inverse value, or we are looking for the value of theta such that sine of theta equal to a certain value, or cosine of theta equal to a certain value, or tangent of theta equal to the certain value. So that's for lecture 27, again, where you have to restrict the domain of sine, cosine, and tangent. However, in this lecture, when we try to solve for trigonometry equations, what you do is we do not restrict the domain of sine of theta, or restrict the domain of cosine of theta, or restrict the domain of tangent of theta at all. What you do is, here is the equation, sine of theta equal to 0. The question is, what are the angle of theta, or what are the values of theta such that sine of theta is equal to 0? This is going to be convenient if you know how to locate the points on the unit circle. Alright, so what the value of theta such that sine of theta equal to 0? So let's go back to the unit circle and see where they are. So here's the unit circle. Again, the points that you see here on the unit circle consists of two components. The first component is for cosine of the angle, and the second component is sine of the angle. All right, so the equation we are looking at is sine of theta equal to 0. You are looking for the value of theta such that sine of theta equal to 0. Now, when you look at the unit circle, you can see that when theta equal to 0, sine of theta is equal to 0. When theta is equal to 180 degree or pi, sine of 180 degree equal to 0. Now, if you continue going around the circle, you see that at 360 degree or 2 pi, sine of 360 degree is also equal to 0. Okay, so the solution to the equation sine of theta equal to 0 is going to be theta equal to 0, theta equal to pi, theta equal to 2 pi, theta equal to 3 pi, so on and so forth. Right. Not only that you can go in the positive directions or counterclockwise around the unit circle, we can also go clockwise around the unit circle. So you can start at 0 and you go clockwise to negative pi, and clockwise again to negative 2 pi, so on and so forth. So therefore, the solution to the equation of sine of theta equal to 0 is any multiple of pi. Theta can be equal to any multiple of pi. For the multiple can be a positive integer, negative integer, or 0. So in this situation, you want to solve for the solutions theta such that sine of theta equal to 0. And from the unit circle, we just examine the solutions are theta is equal to negative 3 pi, negative 2 pi, negative pi, 0, positive pi, 2 pi, 3 pi, so on and so forth. So that the conclusions can be the solution is theta equal to multiple of pi, for this can be equal to n pi, where n can be equal to negative 3, negative 2, negative 1, 0, 1, 2, 3, so on and so forth. Okay, so that's one way to look at the problem. And as you can see, there are infinitely many solutions because we didn't restrict the domain of psi theta at all, right? And again, the property of psi of theta is that the domain of psi of theta is from negative infinity to positive infinity. We so that's for lecture 26. For lecture 27, we have to restrict the domain of psi of theta so that that part of psi function is in one-to-one function so that you can find the inverse of psi. Here in lecture 28, we go back to the general idea of psi function that the domain is between negative infinity to positive infinity. Therefore, in the case of psi of theta equal to 0, there are infinitely many solutions. So I want to mention that there's infinitely many solutions. However, as you can see, sometimes it's a little bit difficult to come up with the general formula like this. So in this case, this is easy that after a certain analysis, we can conclude that, okay, the solution is theta equal to a multiple of pi. Okay, again, sometimes it's difficult to come up with that formula. And therefore, in solving the solution of trigonometric equations, we just need to find the solution in a certain interval, and by convention, we restrict the solution in between 0 and 2 pi, just within the unit circle and rotate counterclockwise. So by convention, we restrict the solution within 0 to pi. So this notations right here indicate this interval is an open half interval where you just include the endpoint on the left hand side and do not include the endpoint on the right hand side. Because remember, so psi function is a periodic function with period 2 pi. So when theta get to 2 pi, everything will repeat again. That means psi of 2 pi is equal to 0 again, and so on and so forth. So that's why we don't have to include 2 pi in the answer. Okay. So with this new restriction in solving trigonometric equations, the solutions from infinitely many, so the conclusions from infinitely many solutions, we can reduce the number of solutions that we have. So in this case, theta is going to be only equal to 0 and pi, right? So that reduces this level of difficulty of the problem down to a lot. Okay, so I hope that makes sense to you. All right, so let me recap what we just do right here. When you consider solving trigonometric equations, for instance, in this case, psi of theta equal to 0, you solve the solutions, and if you don't restrict any interval of solutions, you're going to obtain infinitely many solutions because in general, the domain of sine function or cosine function are from negative infinity to positive infinity. And because of that, it's very difficult to come up with a general form of the solution like this. Therefore, by conventions, we'd restrict the solution within 0 and 2 pi. So therefore, instead of writing infinitely many solutions, you just have 2 solutions. Okay, so I hope that helped. Now, moving on to the following example. So we're looking for, so we want to solve for theta in each equation. Assume that theta is between 0 and 2 pi. And please fix this one for me here. So theta is just between 0 and 2 pi, but do not include 2 pi. So problem A say that, can you find what you want to solve the equation cosine of theta equal to 1? That is, you're looking for the value of theta such that cosine of theta is equal to 1. Now, again, is you need to be comfortable with finding or locate the point on the unit circle. You have to understand where is what angle theta such that cosine of theta is equal to 1. All right, so let's go back to the unit circle again. So this is the unit circle. You are solving the equation cosine of theta equal to 1. In other words, you're looking for theta such that cosine of theta equal to 1. So in the case of cosine of 0, theta equal to 0, cosine of 0 is equal to 1. So that's one solution. And you continue going around the unit circle and you arrive at 2 pi, where you have that cosine of 2 pi or cosine of 360 degree will give you 1 again. So technically there are two solutions, but we restrict the solution, the domain of the solution between 0 and 2 pi, but do not include 2 pi. So therefore the solution is theta equal to 0. Right? So 0 degree or 0 radian. Okay, so I hope that helped you capitalize the idea of how to solve the solution of a trigonometric equations. Now let's move on to problem B, tangent of theta equal to 1. So before we go into the details of this problem, I want to go back to the idea of the preference angle, and I understand that we didn't actually cover the part of the preference angle, but what you need to know is anytime I mention preference angle, I will refer back to the following angles. So the preference angle, and I name that alpha. This is the Greek letter, alpha. And this is going to be equal to either pi over 6, pi over 4, pi over 3. So just this 3 reference angle. Now for tangent theta equal to 1, what is the reference angle that that you need to look for? So go back to the lecture when you have the unit circle. So in this lecture, not only we cover the unit circle, we also cover the table of some trigonometry ratio of some special functions. Okay, so tangent of theta equal to 1, what is the corresponding angle? So tangent theta equal to 1 here. So the corresponding theta is going to be 45-degree angle or pi over 4. So the reference angle that we refer back to, right? So the reference angle is going to be pi over 4 because tangent of pi over 4 is going to give you 1. Now, after defining the reference angle, we move on to find the actual solution theta. And I'm going to call that the angle measure. So for the angle measure or the value of theta, you need to identify theta in quadrant 1, in quadrant 2, in quadrant 3, and in quadrant 4. You don't know exactly until you do more analysis. So therefore, what I could ask you to do for every problem from now on is that can you find the solutions or can you find the value of theta in quadrant 1, 2, 3, and 4 and related that back to the preference angle. So here it goes. So in the first quadrant, the value of theta will be equal to exactly the preference angle. So in this case, is pi over 4. In the second quadrant, the value of theta is equal to pi minus alpha. So I'm going to stick with the radian measure at this point. And you have pi minus pi over 4 equal to 3 pi over 4. In quadrant 3, you have theta equal to pi plus alpha. So in this case, pi plus pi over 4 or 5 pi over 4. And in quadrant 4, you have theta equal to 2 pi minus alpha. So you have 2 pi minus pi over 4. This is going to give you 7 pi over 4. Okay, so with these four solutions, how could you pick out the correct answer? So you look at the value here, tangent of theta equal to positive 1. And remember, tangent of theta can be written as psi of theta over cosine of theta. And for psi of theta is the y value or the vertical axis, and cosine is going to be and cosine is the x-axis or the horizontal axis. So you look at the quadrants such that both sine and cosine give you positive. Okay, so in the first quadrant, so let's take a look at this unit circle. So in the first quadrant, both x and y are positive, so you have one solution in the first quadrant. So this is going to be one solution right here. So theta equal to pi over 4. Now, in the second quadrant, you have the y part or psi is positive, but cosine is negative. So tangent of that would be a negative number. So that's not going to be the solution. So I'm going to erase that. Right. So I'm going to eliminate that. Now, in the third quadrant, cosine is negative, sine is negative, so negative over negative will give you positive. So that makes sense to have the value in the third quadrant, theta equal to 5 pi over 4 as the solution. Now in the fourth quadrant, you have sine to be negative, cosine is positive, so therefore tangent is a negative number, so you eliminate the value in the fourth quadrant as well. Therefore, in this problem, we get two solutions. One is in the first quadrant, theta equal to pi over 4, and the second solution is theta is in the third quadrant, which is equal to 5 pi over 4. And hopefully this gives you an idea how to find theta related to the reference angle, and also how to identify the correct answer for theta depends on the value of the equations given to you. So here theta related to the reference angle is going to be the same for all the problem. In quadrant 1, this is going to be the formula. So in quadrant 2, this is going to be the formula, always going to be the case. In the third quadrant, here is the formula. And in the fourth quadrant, this is the formula. Okay, so we're going to do the same thing for starting in problem C and so on. That's the first thing that we need to identify is the preference angle. And the second thing that we need to do is the angle measure. Inside the angle measure, you're going to write down the relation between the solution theta with the reference angle. First quadrant, theta equal to alpha. In the second quadrant, theta equal to pi minus alpha. In the third quadrant, theta equal to pi plus alpha. And in the fourth quadrant, theta equal to 2 pi minus alpha. And from these calculations, and based on the equations given to you, you can identify if the value of theta is in the first quadrant, second quadrant, third quadrant, or the fourth quadrant, just like what we did for tangent of theta equal to 1. Okay, now let's move on to problem C. Sine of theta equal to negative square root of 3 over 2. So what is the preference angle, you should ask, right? So you have something related to root 3 over 2. Right, so remember all the technique that I showed you in class, but also let's go back to unit circle, try to identify the preference angle. Sine of theta equal to negative root 3 over 2. When you look at this table, you don't see negative value at all, but you see root 3 over 2 related back to sine of theta. Okay, so sine of 60 degree or pi over 3 will give you square root of 3 over 2. So that is the reference angle alpha equal to pi over 3 or 60-degree angle. So for the reference angle, you have alpha equal to pi over 3. Now for the angle measure, what you do is again, you break it down into 4 different quadrants. Right? So in quadrant 1, you have that theta equal to alpha, and that's going to be equal to pi over 3. Quadrant 2, you have theta equal to pi minus alpha, or pi minus pi over 3, going to give you 2 pi over 3. Quadrant 3, you have theta equal to pi plus alpha, or pi plus pi over 3, or 4 pi over 3. And in the fourth quadrant, you have theta equal to 2 pi minus alpha, or 2 pi minus pi over 3, or this is 5 pi over 3. So what is the solutions to these equations? Now you look at the equations again. So the psi value has to give you a negative number. So the negative psi, right? So psi is negative. So you look at the quadrant. In quadrant 1, psi is positive. In quadrant 2, psi is also positive. In quadrant 3, the psi is negative, and in quadrant 4, psi is also negative. So the solutions to this equation should be in quadrant 3 and 4. So theta equal to 4 pi over 3 and theta equal to 5 pi over 3 are the solution to these equations. And you can just eliminate pi over 3 and 2 pi over 3. So I hope this helped again how to identify the solution, how to find the solution of the trigonometric equations. Again, I want to emphasize that there are 2 big steps, which is first identify the preference angle alpha, and then the second is to find the angle measure. Inside the angle measure, you need to calculate theta in quadrant 1, 2, 3, and 4. And then based on the equations given to you, you can identify the correct angle in the corresponding quadrant. Now in example 2, you also asked to find the solutions x of the equations 2 times psi of x equal to 1, and assume that x is between 0 and 2 pi, and please change this to just strictly less than 2 pi. So when you look at this problem, 2 times psi of x equal to 1, you see that you need to manipulate the equations a little bit. So you divide it both sides for 2, and you get psi of x equal to 1/2. So this equation tell you what? Tell you that you need to look for the value of x such that psi of x equal to 1/2. So what angle x that give you psi of x equal to 1/2? So you go back to the table again, and you get x equal to, so x or theta equal to 1/2 right here. So the reference angle is pi over 6. So here you write the reference angle is equal to alpha equal to pi over 6. Now for angle measure, let me move this out of the way. You calculate the value of theta in first quadrant. Right, so theta equal to alpha equal to pi over 6 in this case. Quadrant 2, theta equal to pi minus alpha equal to pi minus pi over 6. Well, this is 5 pi over 6. In quadrant 3, you have theta equal to pi plus alpha equal to pi plus pi over 6 equal to 7 pi over 6. In quadrant 4, theta equal to 2 pi minus alpha or 2 pi minus pi over 6, and this gives you 11 pi over 6. All right, so you have these four values and you want to pick out the correct answer. Now, after doing this calculation, you go back to the given equations right here, or the manipulated equations, and you get psi equal to a positive number, right? So in the first quadrant, psi is a positive value. In the second quadrant, psi is also a positive value. In the third and the fourth quadrant, psi is negative value. So therefore, the answer should be in the first quadrant and in the second quadrant, that is theta equal to pi over 6 and theta equal to 5 pi over 6. And you can exclude these two values, theta equal to 7 pi over 6 in quadrant 3 and theta equal to 11 pi over 6 in quadrant 4. Let's move on to example 3. So in this example, you have cosine of x plus square root of 2 equal to negative cosine of x, and again you want to restrict x between 0 and 2 pi, and strictly for x is strictly less than 2 pi. So again, this is not a straightforward problem. You have to do some manipulations to solve for cosine of x, or to solve for the value of x. Here you start with cosine of x plus square root of 2 equal to negative cosine of x. Now let's try to move everything related to cosine of x to one side of the equations. So negative cosine of x, you move to the left-hand side. Square root of 2, you move to the right-hand side. Here you have cosine of x plus cosine of x equal to negative root 2. Right. Now on the left-hand side, you get 2 times cosine of x equal to negative root 2, and therefore cosine of x equal to negative root 2 over 2. Right. So it's easy to identify the reference angle in this case because we have root 2 over 2. Right, so the reference angle is that alpha equal to pi over 4. And then the next thing you do is to calculate the angle measure. You have quadrant 1, where theta equal to the reference angle equal to pi over 4. In quadrant 2, theta equal to pi minus alpha equal to pi minus pi over 4, or 3 pi over 4. In quadrant 3, you have theta equal to pi plus alpha, or pi plus pi over 4, or this is pi over 4. In quadrant 4, you have theta equal to 2 pi minus alpha, or 2 pi minus pi over 4, but this is 7 pi over 4. All right. After these calculations, go back to the manipulated equations, and you see that cosine has a negative value. So in the first quadrant, cosine is positive. In the second quadrant, cosine is negative. So let me actually use this. In the first quadrant, you eliminate that. In the second quadrant, you choose it. In the third quadrant, cosine is also a negative value, so you choose the value in the third quadrant. In the fourth quadrant, cosine is positive, so you eliminate the answer as well. So the solution to this equation is theta equal to 3 pi over 4 and 5 pi over 4, and you eliminate theta in the first quadrant and theta in the fourth quadrant. Now let's take a look at example 4. So in example 4, again, it's not a straightforward problem. You need to solve for the value of t such that 4 times sine square of t minus 1 equals to 0, for t is between 0 and 2 pi, and t has to be strictly less than 2 pi. Okay. So given this equation, 4 times sine square of t minus 1 equals to 0, you first need to solve for sine of t. So you move everything So what you do is first you move -1 to the right hand side and you get 4 times sine squared of t equal to 1 and sine squared of t equal to 1/4. And to solve for sine of t, you take the square root on both sides of the equations, and you have that sine of t equal to plus and minus 1/2. Okay, so you have two scenarios here, or two equations that you need to solve simultaneously. One equation is sine of t equal to positive 1/2, and sine of t equal to negative 1/2. And because they both related to 1/2, so the reference angle, again, you go back to the table of trigonometry ratios, you will see that the reference angle is alpha equal to pi over 6. So the reference angle, alpha equal to pi over 6 for both cases. Okay. And for the angle measure, what you do is we're gonna do we do the calculation in the first quadrant in the first quadrant, second quadrant, fourth quadrant, and the fourth quadrant, and we can apply to both of these equations. Okay, so in quadrant 1, you will see in a minute that two of the solution will belong to the equation sine of t equal to 1/2, and two solution will belong to the equation sine of t equal to negative 1/2. So for the angle measure, you have the first quadrant that theta equal to alpha and equal to pi over 6. Even though the angle that we're working with is equal to t, but just for convenience of hopefully stay consistent with the calculations we have earlier, so I still use theta, but technically the variable we should use is t. Okay, so in the second quadrant, theta is equal to pi minus alpha or pi minus pi over 6. In the third quadrant, you have theta equal to pi plus alpha or pi plus pi over 6 is 7 pi over 6. This one is 5 pi over 6. And in the fourth quadrant, theta equal to 2 pi minus alpha or 2 pi minus pi over 6, or this is 11 pi over 6. Okay, so what are the solutions here? So in the first equations, you have sine equal to a positive number. So let's work with me here. So sine is a positive number. So in the first quadrant and the second quadrant, you're going to choose the value of theta, okay? And eliminate the value of theta in the third and fourth quadrant. But for the second equation, sine of t equal to negative 1/2, what you do is you eliminate the value in the first and second quadrant, because in the first and second quadrants, the sine value is positive, and you only choose the value in the third and the fourth quadrant. So to distinguish the two equations, I call this equation 1, and the second equation is 2. Now, for the first equation, we only choose the solution in the first quadrant and the second quadrant. So this solution belong to the first equation, this solution belong to the first equation, and this two belong to the second equation. So 11 pi over 6. So technically the solution to this equation, 4 times sine squared t minus 1 equal to 0, is going to be pi over 6, 5 pi over 6, or 7 pi over 6, or 11 pi over 6. What you do right here is separate in two equations and solve them simultaneously, so that it's convenient for us to learn the technique and apply the correct solution to the corresponding equations. So hope that helped, but technically the solutions to this original equation should be all four values. Okay. Now moving on to example 5. So in this example, you have the problem 2 times cosine of theta times sine of theta minus cosine of theta equal to 0 for theta is between 0 and 2 pi and theta is strictly less than 2 pi. So you look at the left-hand side and you see that cosine of theta is a common factor. So you take out cosine of theta and you're left with 2 times sine of theta minus 1 equal to 0. So again, so here you have the term cosine of theta, you take it out and you're left with 2 times sine of theta. On this term, you have 1 times cosine of theta, and you take out the cosine of theta and you're left with just 1. Okay. So you have a product of two terms. Right? One is cosine of theta, the other one is 2 times sine of theta minus 1. So you separate this into two equations. One is cosine of theta equal to 0, and one is 2 times sine of theta minus 1 equal to 0. Okay. So for the case of cosine of theta equal to 0, what you're going to do now you're gonna find the reference angle as well is what value of theta such that cosine of theta is equal to 0. So it's easy to identify that theta equal to pi over 2 is one solution, and theta of 3 pi over 2 is another solution. All right. So theta equal to pi over 2 and 3 pi over 2. In this case, cosine of theta equal to 0. Now for the second equation, 2 times sine of theta minus 1 equal to 0. Now if you go back to one of the equations that we have earlier, so in example 2, you have 2 times sine x equal to 1, and you already solved for the solutions that theta equal to pi over 6 and theta is equal to 5 pi over 6. And we're going to eliminate the two solutions in quarter 3 and quarter 4. So I'm going to bring this to the solutions. I'm going to bring these two solutions down into example 5. So the solutions are theta equal to pi over 6, and theta equal to 5 pi over 6. So in conclusions, there are 4 solutions for this particular problem. The solutions are theta equal to pi over 2, theta equal to 3 pi over 2, pi over 6, and 5 pi over 6. Now let's move on to example 6. So for this example, we would like to find the value of theta such that tangent square of theta minus tangent of theta equal to 0. For theta is between 0 and 2 pi, and theta has to be strictly less than 2 pi. So tangent of theta is a common factor. We'll take out one tangent of theta here and one tangent of theta here. So you get tangent of theta, and you're left with tangent of theta minus 1 equal to 0. So again, in this case, you take out one tangent of theta and you're left with one tangent of theta. Here you have 1 times tangent of theta. After taking out tangent of theta, you're left with 1. Okay, so you have a product of tangent of theta and tangent of theta minus 1 equal to 0. So you solve that tangent of theta equal to 0 or tangent of theta minus 1 equal to 0, and you solve these two equations simultaneously. So here on the left-hand side, you have tangent of theta equal to 0. So remember, tangent of theta is can be written as a fractions of sine of theta over cosine of theta. So technically, what you're looking for is looking for the value of theta such that sine of theta equal to 0. Let's go back to the unit circle. So in the unit circle, again, you have sine of theta, sine of 0 equal to 0, sine of pi equal to 0, and sine of 2 pi equal to 0. But remember, theta has to be strictly less than 2 pi, or so we have to eliminate the answer of 2 pi. So there are just two solutions for the case of tangent of theta equal to 0. So again, what I mentioned earlier is sine of theta over cosine of theta equal to 0. So you have to find the value of theta such that sine of theta equal to 0, and there are only two solutions, theta equal to 0 and theta equal to pi. Now for the second equations, tangent of theta minus 1 equal to 0. So you solve for this and you get tangent of theta equal to 1. So you saw this problem earlier in example 1b, and you get the solutions to be equal to pi over 4 and 5 pi over 4. So if you have questions on how to solve this, please go back to example 1b. So the solutions are theta equal to pi over 4 or theta equal to 5 pi over 4. So there are four solutions in this particular equations when theta is between 0 and 2 pi, or theta is strictly less than 2 pi. Those solutions are 0, pi, pi over 4, and 5 pi over 4. Now moving on to example 7. Again, the idea is to solve for the angle theta such that 2 times cosine squared of theta plus cosine of theta equals to 0. Let's manipulate this equation. So 2 times cosine squared of theta plus cosine of theta equals to 0. So you see here, compare these two terms. You have cosine of theta as is a common factor. So you take cosine of theta as a common factor out, and you left with 2 times cosine of theta plus 1 equal to 0. Okay, so hopefully you can see the idea here that cosine of theta is a common factor. After taking out cosine of theta, the first term still have 2 times cosine of theta, and the second term only have 1 because cosine of theta times 1. Now here is the product of two terms, cosine of theta and 2 times cosine plus 1 equal to 0, and therefore you get two equations, cosine of theta equal to 0 or 2 times cosine of theta plus 1 equal to 0. And you're going to solve these two equations simultaneously. You have seen cosine of theta equal to 0 earlier already. So you're looking for the value of theta such that cosine of theta equal to 0. The values are pi over 2 and 3 pi over 2, right? Remember, again, theta is between 0 and 2 pi, for theta is strictly less than 2 pi. Now, for the second equations, you have to manipulate these equations to get cosine of theta by itself. So what I do is I move 1 to the right-hand side, and I get 2 times cosine of theta equal to -1. And then divided both sides for 2, I have cosine of theta equal to -1/2. Okay, so what you do now is you find the reference angle and then the angle measure. So let me move this out of the way for the time being. Remember, we are working on this equation to cosine theta plus 1 equal to 0. You manipulate the equation to arrive at cosine of theta equal to -1/2. So cosine of theta equal to -1/2, so it's related to 1/2. And the reference angle should be alpha equal to pi over 3. Okay. Now, after you get the reference angle, you do the angle measure when you calculate the corresponding theta in every quadrant. Right? So in quadrant 1, theta is equal to alpha equal to pi over 3. In quadrant 2, you have theta equal to pi minus alpha equal to pi minus pi over 3. Well, this is 2 pi over 3. In quadrant 3, you have theta equal to pi plus alpha, or pi plus pi over 3, or this is 4 pi over 3. And in the last quadrant, quadrant 4, you have theta equal to 2 pi minus alpha, or 2 pi minus pi over 3. This is equal to 5 pi over 3. Now, after calculate the angle measure, you go back to the equation and see that cosine has to be a negative number. Right? So when cosine is a negative number, you only choose the solutions in the second and the third quadrant. Because in the first quadrant, cosine of theta, or the x-axis, is positive, and only in the second quadrant and third quadrant where you have the cosine of theta equal to negative, or the horizontal axis is negative. So you eliminate the solution in quadrant 1 in quadrant 4, but you choose the solution in quadrant 2 and quadrant 3. So here the solution, and you eliminate these two choices. Okay. So again, in this problem, you obtain 4 solutions for theta. Theta equal to pi over 2, 3 pi over 2, 2 pi over 3, and 4 pi over 3. Now let's cover the last example here. In this example, we'd like to solve for theta such that tangent of theta minus 1 altogether times sine of theta minus 1 equal to 0. So this is a product of two different terms, or two different expressions, and they are equal to 0. And you can rewrite this as so that you can solve two equations simultaneously. So one equation is tangent of theta minus 1 equal to 0, or sine of theta minus 1 equal to 0. So tangent of theta equal to 1, and sine of theta equal to 1. Now, tangent of theta equal to 1, we already see that a couple of times. So the solution should be theta equal to pi over 4 and theta equal to pi over 4. So one solution is in the first quadrant. This solution is in the third quadrant, because again, tangent of theta is equal to positive 1. So you want both sine and cosine to be positive or to be negative. Now for sine of theta equal to 1, there's only one solution, and that is theta equal to pi over 2. Okay, so in this equation, or in this example, there are 3 solutions. One is pi over 3, 5 pi over, one is pi over 4, another one is 5 pi over 4, and the last one is pi over 2. So that's it for me for this lecture. Please let me know if you have any questions. Thank you.